So welcome back to my channel GATEquestionsECE, and let's see what's the next question. So next question with the question code 104. Consider two uniformly distributed independent discrete random variables x1 and x2 such that x1 is uniformly distributed over -1 to 1 and x2 is uniformly distributed over 0 to 2. Then we have to find following two probabilities. See, one of the standard method that we usually use in such problems is we assume that x1 plus x2, let it to be another random variable, say z, which is equal to x1 plus x2. Then we use the discrete convolution method to find the PMF of z from the PMF of x1 and x2. Similarly, in part B, we assume it to be another random variable z, which is equal to x1 minus x2. And in this case, the PMF of z will be discrete convolution of x1 with reversed PMF of x2. So that is the standard procedure. And then this problem A will reduce to probability that mod of z is less than equal to 1, which is nothing but probability that z is greater than equal to -1 and less than equal to 1. And from the PMF of z, we can easily find out this. Similarly, we can do for the part B. But in this solution that I am going to give you, I will be using the shortcut method that I discussed in problem 103. The link of that problem I will provide here in the I button and in the description also. So let's see how to solve this problem using the shortcut method that I discussed in question code 103. So it's given in question that x1 is uniformly distributed over -1 to 1. So x1 can take three values, -1, 0 and 1, and each with probability 1 by 3 for these three cases. Similarly, it's given that x2 can uniformly take values from 0 to 2. So x2, here it is x1. So x2 can be 0, 1 and 2. And corresponding probabilities will be 1 by 3 for each of these three cases. So now we can write the joint PMF. So joint PMF will be, it will be equal to product of marginal PMFs, because x1 and x2 are independent. So here it will be 1 by 3 into 1 by 3 for what values of x1 and x2? For 9 values of x1 and x2 that we can form from these two sets of x1 and x2. So when x1 can be -1, x2 can take these three values. And so we get three ordered pairs. And these three ordered pair corresponds to these 3 points in x1 x2 plane. Similarly, for x1 is 0, x2 can again take these three values. So we get these three ordered pairs or points in x1 x2 plane. Similarly, we can get these 3 points. So for these 9 points in x1 x2 plane, the joint probability is 1 by 9. So in A part, it's asked about the probability x1 plus x2 is less than equal to 1. Its mod is asked in this question. We know that for mod of y less than equal to x, we can write it as y greater than equal to minus x and less than equal to x. So similarly, we can write this probability as the probability that x1 plus x2 is less than equal to 1 but greater than equal to -1. So we need to find out this probability. So this probability is the probability of the region that satisfy these two inequalities. So let's see what's the region in x1 x2 plane that is defined by this inequality. So on the right side we can see it's bounded by x1 plus x2 is less than equal to 1. So let's see what's the right side. It's saying x1 plus x2 is less than equal to 1. We know that this line I have drawn here, this line is x1 plus x2 is equal to 1, and above this line, all the region that is lying above this line is the region for which x1 plus x2 is greater than 1, and all the region that is lying below this line is the region that satisfies x1 plus x2 is less than 1. So the region that is defined by this inequality will include the region on which x1 plus x2 is 1. So this entire green line here, as well as the region for which it is less than 1. So this green boundary plus the region that is lying below this boundary. And similarly, we can see the right side of this inequality. It states that x1 plus x2 is greater than equal to minus 1. So we can see the region corresponding to this inequality will be the region that includes this x1 plus x2 is equal to 1 is equal to minus 1 line. So this line, this whole line, plus the region for which x1 plus x2 is greater than minus 1. So the region for which x1 plus x2 is greater than minus 1 is the region that is lying above this line. So for this region that is lying above this line is the region for which x1 plus x2 is greater than minus 1. And similarly, for the region that is lying below this line, x1 plus x2 is less than minus 1. So this inequality covers the region that includes this infinite line plus the region that is lying above this line. So now we know the regions that are included in both these inequalities. So the region that is covered by this inequality is the region that is common to both these equations. So the region that is common to both these equations is the region that is lying between these two lines as well as includes these two lines. So this probability will be equal to sum of all the joint probabilities that are lying in this region. So it will include all these 6 points that are lying in this region. So sum of the joint probabilities of these 6 points will be 6 by 9. So this probability will be equal to 2 by 3. So this is the desired answer for this probability. Similarly, we can do for the case B, in which he has asked about the probability mod of x1 minus x2 is greater than equal to 2. Because of the lack of the space on this page, I will solve this problem on next page. I have copied the previous data here, and in part B they have asked about this probability mod of x1 minus x2 is greater than equal to 2. And we know in mathematics, we know that if mod of y is greater than equal to x, we can write it as combination of y is greater than equal to x union y is less than equal to minus x. So using this notation here, we can write this probability will be equal to probability x1 minus x2 is greater than equal to 2 union x1 minus x2 is less than equal to minus 2. I am writing this as region 1 and this as region 2. So you can see that region 1 is the region that includes x1 minus x2 is equal to 2 line plus the region in which x1 minus x2 is greater than 2. So you can see here in this diagram x1 minus x2 is equal to 2 line, this is the line, and x1 minus x2 greater than 2 is the region that I have drawn here with yellow line. So region 1 here includes the region in which this x1 minus x2 is equal to 2 line is included, as well as this yellow region is included. Similarly, the region 2 here, you can see here it includes the region in which x1 minus x2 is equal to minus 2. So this line here that I have drawn here, this line is included in this region, plus the region in which x1 minus x2 is less than minus 2. So it includes this x1 minus x2 is less than minus 2. So this blue region here. So the region included by this region 2 is the region which includes this boundary as well as this blue region. So this inequality includes both of these regions. So this inequality includes the region, this blue region, this yellow region, as well as these two infinite lines. So we can further write this expression as probability. This I am writing as 1 plus probability of 2 minus probability 1 intersection 2. So you can see there is no common region or intersection between region 1 and region 2. So this probability is going to be 0. And this probability will be equal to the sum of all the joint probabilities that are lying in region 1. So region 1 is this yellow region plus this infinite line. As you can see, out of these 9 points, no point is lying in region 1. So this probability is also 0. So this probability will be equal to the sum of joint probabilities that are lying in region 2. In region 2, we can see there are 2 points that are lying on its boundary plus 1 point that is lying inside this region. So this will be equal to sum of the joint probabilities of these 3 points. So sum of joint probabilities of these 3 points is 3 by 9. So this probability will be equal to 3 by 9, or we can write it as 1 by 3. So I hope you have learned this graphical way or the shortcut method of obtaining probabilities, and it will increase your knowledge about probabilities. So thank you for watching this video, and please be in touch for more videos and do subscribe to my channel. Thank you for watching this video.